Hello friends, welcome to Tech on Target. Today we are going to learn about Kubernetes architecture, how Kubernetes architecture work and what are its basic component, how we can communicate to Kubernetes, and what is master plane, what is worker node, or we are going to see that. If you are already watching my channel, you have seen that all my videos on Kubernetes are in Hindi language, and for my today video I'm going to show this in English language, so that audience who understand only English language can relate to us and get benefit from our videos. So let's start. So I divide this small diagram in two parts. One part is for our master plane, and second part is for our worker node. One thing I should add here, for master plane, when we are working on on-prem system, we should have to take care about where should we place our component like control manager, etc. But in when we are in cloud, like we are choosing the cloud hosted AKS via Azure or AKS via AWS, same other cloud also providing the like Google also providing. But for that we don't have to much care about the master plane. Master plane, all responsibility will be taken care via cloud only. We just have to take care of the rest of the thing, our application only. But if you are going to on your on-prem system, you will need a more team to manage the things. So let's start. First part I cut down for the master plane. In the master plane, first part is the control manager. Control manager is the core component of the control plane, which takes the routing decision and other things. But when we hit the Kubernetes API, like we are doing the kubectl get nodes, where we hit the API server. API server is the only component which can talk to any component of the Kubernetes. And while we are doing communication, we forward our request to API server only. When API server we give our request to API server, it will forward it to control manager, and then we have control manager which will communicate with the API server only. And if we are going to appoint some resources, then request will forward it to the kube scheduler, and kube scheduler will check at which worker node resources are available, and compare the resources which there is a one small worker node, there is one larger worker node, and it will schedule on the larger worker node. And once it takes the decision, API server will write it on etcd. Etcd act as the database where all the configuration, everything is stored in the etcd, and it writes on the etcd, and then it will create pod, and after creating pod, it's again write to etcd that this task is done. So whatever you are doing, you can see that API server is at the middle for the communication. Nobody can talk to etcd directly. To make our Kubernetes highly available, main power is our configuration. If something gone disaster happen, and for in case of clouds are providing the highly availability assurance for 99 availability of the kube master. But which can cap the etcd configuration to make our system highly available. And it is admin or maybe some user, some your NOC team, the different permission you can give, like admin have full access, some user have only view access, and NOC team only just have limited access to some services, don't have access to create service count, cluster role, etc. And that's complete our master plan. And at other end we are taking example of two worker node, and worker node will have two major component, kubeproxy and kubelet. What is the task here for kubeproxy and kubelet is, kubeproxy is taking care of the all network related concepts like assigning IPs and make your ports communicate to other request, and kubelet to manage the pod under container. Whole management will be taken care by kubelet only. So once your system is done and you run you or your team is running the Kubernetes command, your service, your application will be created in a container which will be comes under the pod. In one pod we can have one container, or we can have more than one container, but it keep as a good practice to make create one container per pod, because containers are highly coupled with each other. If for example you have two containers, if one container go down and other is working, it is not like that your one container will be created, whole a new pod will be created where you will see it will create two new container, and via creating these new containers, when this new container, the old pod will be get deleted. So most of the cases we create one container per pod. In some special cases only where we have some specific requirement where we use the two container or as per our use case. So kubeproxy, kubelet, when we have to send our request to create pod, to do some changes, API server is the first person with which we will talk, and it also it is the communicating to internal components of the master plane and component of the worker node plane. Let's start with EKS cluster. We will create EKS cluster by using our AWS console. For that we need first of all we need an infra like VPC, subnets, etc. There is a template available on the portal of AWS and blog. Their documentation is available to create, but you know how we can create VPC, what are the requirements. So just we create simple VPC and two subnets where we can create our infra for AKS cluster for this video of demo purpose, and then we will move on. Then we have replaced the name as per our requirement, and we don't need private subnet for this time demo. We will implement private cluster later on section. So now we have VPC, subnet, route tables. You know how we can configure this. Videos are already available in Hindi language to configuration of VPC. We don't need these gateways of VPC endpoint, so we will select it to none, and we are good to go to create the infra. uh, just validating, and you can create by manually by creating. You can do more stuff, breaking the subnets into different uh, portion, creating the VPC cider and subnet cider according to what is your requirement section. So let's create the VPC. It will just take 1 minute or less than 1 minute. Oh, it's created. So VPC is now created. You know very well VPC, it is a virtual private network where we can host our infra securely because it's a private network. We need to change little bit of settings here. We need to enable the auto assign public IP feature for the subnets. If we don't do this, we will have the error while creating worker node for our Kubernetes cluster. So okay, enable. We have two subnets this time. We are just creating this. Do the setting is part is done. So let's move to the Amazon EKS. So before creating EKS, we need a IAM role for that. IAM role creation is very easy. We need to go to IAM, then in the create in the role section we need to create the role. We need to create the role for EKS, and on service we will select EKS cluster, and Amazon EKS cluster policy we will attach in permissions. This policy is enough for EKS cluster, so we will do next. Then we will give it is a name. Name is as per your understanding. You can give any name. I've already done this demo, so one is already ready. I'm giving its name as 2, and policy is getting attached, and we will create the role. You can see there policy is there. So it's creating within 2-3 seconds. It's created the role. So first part of cluster creation we have done. So we will create a cluster. We will doing this our work in Ohio work area. Demo cluster, whatever name as per your understanding or your use case, your client requirement you can give. We are using the latest Kubernetes version and attaching our IAM role which we have just created few seconds ago, and we will go next. Select our VPC we have created just, and subnets auto come there, and security group we will select default one for from where we can control the security in outgoing traffic. And there are 3 types of cluster endpoint available, like public and private. So we will choose the public and private, where the endpoint of the master is accessible from outside, and private worker node their endpoint are not accessible. So we will choose this public and private. There are in client side I have seen there are mostly they have they configure the private only. So in this demo purpose we are using this purpose. So you can configure logging for the API service audit authentication, but we don't require the logging setup now. So we will continue for the next. These are the case for the CLI version and other stuff. So we're just validating it. So we are selecting is as per the latest version. If your Kubernetes version is not as per latest, to migrate it to the latest version. So it's getting created. It will take around 10 to 12 or 8 minutes for creation. So we can utilize this time meanwhile, because we have some work there. Like we need to assess via instance. We will launch instance. So let me create a EC2 instance from where we can assess. So we can assess it from the same VPC, and we have made it public, accessible from public endpoint. So we can use different VPC also. So I don't have any VPC. Let me to create one more VPC, and we will use then this VPC. So I have created a default VPC. I'm using the default VPC, and subnet preference I'm not giving, and creating a simple T2 micro instance. I hope you are enjoying the video, and this is beneficial for you. You should give your feedback. So we are ready with the worker node. Cluster is still creating, so we will let him create it. Our instance is in pending state. It will just take 10 to 15 30 seconds to create log. It's now in running state, connected, and we will connect it over a browser. You provide a security group to connect over your IP only for security, but I'm going to delete this instance after the demo purpose. So I can go with the open all IPSS 00/0 So to access the cluster, we have this document provided by the AWS. So we have some pre-requirements. This template you can use to create the VPC, but we have created manually. Then we have some dependency like kubectl and AWS CLI. So let's install them, configure them on your system. First we create the AWS CLI, install the AWS CLI. AWS CLI purpose of installing and configuring AWS CLI to authenticate with the AWS, because we are using this time AWS, but you can use your own local system to communicate, to access the cluster. So how you can authenticate to AWS? You should be a valid user. For that you need AWS CLI to be configured on your system. That is a mandatory part. You have to do that. These are just 3 commands which we need to run for installation part. Configuration part is we will do after that. First we will do installation. Maybe it got failed because we don't have unzip. So let me install the unzip. Unzip is getting installed. AWS CLI, we have unzipped our files, and then we will install it, and we are ready with the AWS configuration. Then we check we have successful configuration or not by checking its version. Then we configure the AWS profile. We can use IAM role for that. In this case, because most you can to configure it over your local system, you need to configure the AWS CLI by using the credential, secret key and secret. So it will take just around 1 to 1.5 minutes. So after that we will install the kubectl. Meanwhile it is getting installed, I tell you the use case of kubectl. We have the AWS just get installed. AWS -- version. I think we have just unzipped the file. We need to make we need to run the last command, sudo dot aws/install. It will create a soft link and activate your binary. Now if you do the AWS configure or AWS -1 version, you will have the AWS CLI configured. So second step is also done. First step was creating cluster, then AWS CLI. Third step, after installation we need to configure. So in the credential section you have to configure the security key and its secret. How we create that, I have already made that video in Hindi language. Same I will try to post on English language. Let's configure. First we have given the key, then we give the secrets, then we have option for location, then we are working on Ohio, and code for Ohio is US-East2, and we will enter that US-East-2, and default format for is JSON, and I don't want to change it. So let me run this command aws ls3ls. So it not given us any error, and it's got successfully executed. It not showed any output because I don't have any bucket is configured. So we have done with our first prerequisite or first mandatory field to access cluster. Then we will go for kubectl. One thing you always keep in your mind when you installing the kubectl is specific for Kubernetes version. Like for 1.24, which we have configure the cluster we have configured is of 1.24 version. We should configure the use the same version. Like this Kubernetes kubectl binaries for the Kubernetes 1.24, we will use that binary, and we will use the AMD link because our EC2 instance is AMD type. So it's getting downloaded. There are different versions, different binaries are available, but we need to execute this binary. So that is the command. First we need to make this binary executable. Then we have to make some directories and push our directories to a specific path. Like in the /bin, we are pushing it into /kubectl over there, and making it export. This export is a temporary one, so we should make this command in the bash src. Yes, we have that option command available here to move that in bash src. Let's run that command, and after that we have the kubectl. Because we have done all these things, let's configure, let's check, validate the kubectl version is get installed or not. So we have done that. Second requirement is also done. Let's check the cluster status. Yeah, that is also configured, so we have utilized that time very well. So we need to create kubeconfig or update kubeconfig to access the cluster. Otherwise you can't access the cluster. We'll run the command. Before running this, we will change the region code plus the name of the cluster. We are doing everything in US-East-2, that's Ohio, and name is my cluster there, but we have a demo cluster name. Let me check. No, that one, demo cluster 1. Okay, we have run the command. Okay, it is telling us that it has added the new context in the .kube config. So if you do check there, we have a file there, .kube. We have a folder there in which we have the config file. You can check the cluster information is authentication, validation, all are available here for now. If you run the Kubernetes command, kubectl command, to access the Kubernetes, we will get the output that's on screen. We are able to access the cluster. So our half portion of configuring cluster is done. So what we need now, we have a cluster, but to deploy any application, we need to run the pods. Where will pod runs? Pods will always run on your worker node, so we need to configure the worker node. So in the AWS service, we will select the EC2 and we have to give here 3 permission. Let's search for EKS. If you search EKS, first is the Amazon EKS worker node policy, then Amazon EKS CNI policy, and one more policy we require, that is the EC2 container registry read only. For that we need to search that container registry. I guess we have to remove that's, I think second one is that we have to just give, because if you are reading the files from the EKS registry, if you are using the ECR, then it is very important for that. And we are gone worker node roles. We are just giving a name. Role 1 is already there, so I'm creating roles by name by giving integer in that numeric value 2, and we will create our role. 2 to 3 seconds will take to create the role. So once we created the role, we will move to cluster, just verifying that policies is getting cluster or not. In the compute section, if we go, we have a node groups. We will add the node groups, give a name as per your understanding, your requirement. Then we have the node IAM role. Just give the IAM role for the node which we have created, and No need to keep the taints selects. Taints video is also available on channel. Then Amazon Linux on demand. Any you can select the worker node from these uh, AMIs, and type of worker node you can change from here. You can also change its disk size. 10 GB disk size is enough. We don't need 20 desired size. Okay, subnet. Okay, these two subnets. I have already configured the two subnets over there. We are ready to add the node group, so we will create that. You can see on screen, if you see the status of node group demo, it's in creating state. If any issue comes, you will find that issue in health issues. Till that this time there is no issue is coming. It will take 2 to 5, or sometime it will take to 10 minutes, sometime only. Otherwise within 5 minutes it created. So I've had post the video. Now it's get created. Now you can see we have the two instances over there. We can see the node, any health issue we got. So if you see, we have only created the one EC2 instance. Now you can see there two instance with the T3 of medium size is get created. If we search here, okay, we are getting the worker nodes listed there. So our configuration of Kubernetes cluster is completed. But I just want to confirm one more thing. In case you are not using the cluster, you don't have to pay for that. You just need to go the compute section and edit the node group. Just select it, then edit it, and change the desired size from 0 here, and minimum size is 0, and you will see that your nodes are getting shut down. Its process also take 5 to 10 minutes. Currently they are in a running state, and it is updating the changes, and after that it will start implementing it. You can visit our channel for videos of like JFrog Artifactory, Wazoo tool. We have also video on AWS and Azure. It's still updating. Okay, status is active, so it should started yes, it has started to shut down the worker node. First worker node, it's start to shut down. It is in currently in shutdown, not in terminate, fully terminate state. Once it gets fully terminated, then it will execute the termination of second instance. Hello friends, welcome to Tech on Target. In today's video, we will see how we can create the AKS cluster. AKS is the Azure hosted Kubernetes services. in these services, the control plane configuration is managed by the Azure, and you can see on Azure portal by a name of Kubernetes services you will find the Kubernetes service, and when you click on create new cluster, and you will move to a new screen or new options where you have to fill some basic requirements. And here in Azure, all the things are associated with the resource group. And that is the logical boundary. If you are not familiar with the Azure, you can view my other videos on Azure. These videos are in Hindi language. I am planning to upload this video in English language soon, so I can connect with the with my friends who can only understand the English language only. So let's start the today demo. And here we have the subscription is the free trial. I'm using a free trial account, so I have to use the free trial. Otherwise, you whatever subscription you have, you're going to use that subscription. Resource group. Let me create a resource group. For that, we will click on the create new, and we will give name of our resource group. For creating resource group and other resources, you should follow the proper naming convention. Here for the demo purpose, I'm only just entering the just a name for demo AKS, but whatever your organization, whatever the use case, you follow the Microsoft official documentation on the how you can name the in proper convention. Then this cluster build configuration, then we have cluster name. Whatever the name you want to give to your cluster, you can give according to your environment, your application path, whatever is your use case. Then in which region where you want to deploy your application. I have seen in some organization there is a limit to, like you should have to only kept your application in India only, like some bank sector or other stuff. And then you can select according to your requirement reason. Then availability zone, in zone 1, 3 zones are there. You can select 3 zones to make your Kubernetes cluster highly available. In case of disaster, you can recover, and you can giving the options to cloud to make the Kubernetes managed on this setup. Then we have different price structure. For now, we are just keeping this as standard, and select the Kubernetes version. I'm using the default version, but if you are your application is familiar with the some specific Kubernetes version, then you should create that only. Then we have to select the instance size of our worker node. But when you select this, I am selecting the B2 as, because I have one condition here. I'm using the free account. In free account, in one region, you have only 4 core CPU quota. You can't exceed that. If you do the configuration which is exceeding this limit, then you will feel this problem. Your worker node will not get created, and if your worker node get, it will throw you error, and your cluster is not ready to host your application. And we are just selecting the 2 worker nodes here, and then we have node pools, and here the node pools, you can select the Linux, and you can create more than one node pool, and you can scale these node pools according to your requirement. And in that particular agent pool, we are having the node count is equal to 2. And you can make the other OS like Windows and other whatever your requirement is. You can just go and pick up your required information. But most of the cases I see we are using the Linux notebook. So that's the playlist at our channel, which where we have uploaded all the videos regarding Azure services, Azure portal services, which will give you the basic and basic to advanced idea how Kubernetes work. So we are at the access section. How your Kubernetes and who will access? Like you can't give access to anyone in your team to create the cluster or service count and other stuff. Only limited minimum privilege should be given. You can do it via local accounts or Azure AD. Azure AD is getting very popular for authentication, and it's very widely used with the AKS. On many organizations I have seen they are implementing this, and Azure AD is good. You can go for our demo purpose. We are just going with the local accounts. We just have to do the Azure login and things are ready. And here is security section, traffic routing session. Not much we need to do here. Then next tab or next is integration. You can integrate it with the Azure Container Registry, and you can into integration now, or you can do integration later on also. So then we have the advanced section, and here we have the tags section. Tags are optional, but it is the best practice to use tags in your infra. Then to validate our setting, we need to click on review and create. Whatever settings we have given, according to that it will give you, if your settings are valid, everything is perfect, so it will give you this validation passed, and you can create the cluster. When you create the cluster, you need it will get created, and when you access it, you need on your system Azure CLI, plus you need kubectl there. How to install the kubectl? I have already made the video when we are creating the EKS cluster, so you can go and watch and create the EKS cluster, that video. Most of the steps are same. Kubectl installation steps will remain same for both. Same utility will be used for both. And now our cluster is ready. I have just paused out the video, and we will click on the connect, and when now I think you can see the whole screen. You will see this command. Before running this command, you should log into your account by doing Azure login. Now I have already done the Azure login, and that is the spell, and on terminal you need to run this. Then a link is open that you need to open on your browser, and a code was given to you that you need to enter on the link and confirm. So now I'm not going to do this. I will run this first command. It is doing? It's setting the subscription on my local system, and then I will get the AKS credits and it will save in my .kube config. Wait for, yes, it's saved, and I'm gonna merge demo as cut. Okay, it's done. Now we are ready with the authentication part. If we hit the Kubernetes API, we will get our result. So let's how we hit the Kubernetes API. We will hit the kubectl get nodes, and you will found the result that you have two nodes. When we are making the configuration, you see that we have selected the two nodes as the configuration part. Others you can check by typing. In today's video, we are going to discuss about a practical scenario and what solution Kubernetes offer to solve this. Like when we create object, for example pod, we are creating a pod, and it's of a specific, it has a specific requirement, like some specific CPU and some like memory requirement. What scheduler do, it look for the resources, whatever the node have the resources, it schedule the ports on that or your objects on that particular node, and it only work upon that. But in some scenario, like when we have to make our application specific, that's our playlist on Kubernetes in Hindi language. I'm started this initiative to make videos in English language, so that audience who only understand the English language can connect with us and get benefit. So come back to our today point. So I have a need, I have a requirement to make schedule the pod on specific node, worker node, or some specific worker node which have memory optimized or CPU optimized. So what we can do to in that particular scenario? So we can do that by using different features of Kubernetes, like node selector, and other features are also there. We will discuss in the video, node affinity and all that. First we will discuss what is node selector and what it offers to us, how it solve our problem. Like its name suggesting, node selector, it is used to select the node. Whenever we need to select the nodes for purpose, for any purpose, our use case, we will tell the Kubernetes via our YAML file that we need to select this node for scheduling, and it will also it will done through via help of labels. Here there is a term like we in AWS. I hope you are friendly with the cloud system. In Azure and AWS, we use the tags, and via tags we give a unique name or give a reference name to our resources. So that's our YAML file of node selector. In that we have YAML file in which we creating a object pod, giving the pod name Nginx and giving us a level of env staging, and we are using the public image of Nginx, and also we are using the node selector. What in the specs field you are seeing the node selector, it is saying that where we have labels of size large. This means that the worker node which have the label of size is equal to large, you need to schedule this pod on that pod only. So when we have if you see the requirement on T2 medium, and it will let down to downtime to for other application also. So where we will find the T2 large instance, only on that instance this particular pod will be deployed. If we do the get nodes, we have the two nodes, and to see the labels, we need to pass the -- show labels flag. I think I am doing the spelling mistake. It's not labels, it's labels. LAB. So you can see that currently what are the current, there are some by default labels which Kubernetes put on your worker node, so that everything is working on a mechanism. Label are part of that mechanism. Kubernetes use this labels feature to make system working. So I hope you are very much now familiar with the labels and node selector. If we apply or if we apply this particular YAML file, our object pod will be created, and you see pod nginx is created. And is it get scheduled? Because I am not seeing any labels where name of size is large. So as per my opinion, my observation, node will it will not get scheduled. So let's see. We are doing this all stuff in a simple namespace and -n test. Okay, and here kubectl pods -n test. Okay, nginx 0/1. Okay, we are created a pod which is in pending state. It is not created. So when your application is not getting deployed, what you can do, you need to check logs either through logs command, and you can describe the pod. It will show you the current logs, which current events which occur with respect to your pods. -n is a compulsory part, and you see the last warning, failed scheduling. Why should failed scheduling? Because there is a node selector which is working, and we don't have that particular requirement. We are not meeting the particular, that's why scheduling is pending. And here you can see that it has a label of size equal to large in the node selector. So what we have to do, there is no labels of such name size equal to large. What we can do best, we can make that label like kubectl labels nodes and node name, and the label we add in key value pair, like label we want to put size equal to large. In that way we will pass here size equal to large, and we need to put the name of the worker node. Okay, size equal to large, and you will see magic will happen, and our pod will get scheduled. I request you all to please subscribe to my channel to support us, to motivate us to work more hard and make more useful stuff. Please subscribe. So that done, you can see that we have the labels size equal to large. So in the particular node which have the IP ending with the 77, it will get scheduled on that. Now you can see that that's warning gone, and it scheduled our what we can say, schedule the pods. And if we check the pods condition, health check, it's in running state and ready one by one. So your application is ready to be worked upon, and you can make your application live and whatever stuff you want to do. Okay, that's the node selector. There are some limitation with the node selector, like we can only work with particular labels, and when I want to make the like function or perform more things like select the node where size is equal to large and extra large, or whenever I want to deploy the pod on node which node have size equal to micro. If size is greater than micro, you can do whatever resource you find, you can schedule over that. So at those cases, node selector will not help you. What will help you is node affinity. Node affinity is now we are going to friendship with the node affinity. So what affinity is saying, it's giving us the choice to select either we can do hard select or we can do soft node affinity. Like you can see on that YAML, we have a env staging, and on that we are making a container of nginx, and we are giving it the name of node affinity dem. Affinity under affinity we are defining the affinity required during scheduling, ignore during execution. Means it's a hard kind of node affinity that this tags must be there, either large or either small must be there when we are doing scheduling. Once it gets scheduling, if someone remove the tags, it will not affect its working. Like once the pod gets scheduled on large or small, whatever is free, it gets scheduled, and it's in a working state, and someone of your team member will remove the labels from the particular node, it will not get terminated. But at the same time, if you make it required during execution, and your team member by mistake or whatever they have done, if they remove the tag, your pod will also get terminated and your application will go down if no other node have that same tag. Okay, and then that is it's a syntax. We give a match expression in which that we provide a key, and we tell him to how to operate. In operator we are defining in, not in exist, not exist, that kind of stuff we can do. Like we can do here not exist, not in, where we don't have large and small label, schedule the ports there. Then instead of require, we have the preferred during scheduling, that if some node have labels of like zone 1 and zone 2, we will prefer them. If not an issue, you can schedule your application pod on whatever your resources you are finding. It's not hard, kind of. Like you have 3 node, and no node have the labels of label of zone 1, zone 2, and any other if you are mentioned that. So it will not going to give you the warning what we find at when we are doing scheduling for the key maximum size equal to large. It will just schedule. It's soft kind of. If it is find that zone 1, zone 2, it will schedule on that only. So that is the preferred and required scheduling during scheduling. So we are ignoring this on execution time. Okay, so when if we move ahead and apply this YAML file, we have a large size equal to large one, and we don't have small one. If you see there, we don't have small one. We have only made labels in the first part for the key size equal to large. So if it's either got the large or small, it will schedule it. So first we are deleting the resources what we made in the node selector to better optimize. If your resources is not getting used in your application, you can remove that. But if you are working in a project, you should go to your project team lead that this resources is not in use. It's just using our valuable resources. We can read that. After their approval, you can read that. Now you can see that Node Affinity demo 3 port is in ready and running state. If you see that we don't have any labels with the name of zone 1, zone 2, but still it's get scheduled and it's ready to serve you, and your application will be live. Yes, everything we are working in test. These are the events of our Node Affinity pod. What it's saying, successfully assigned test that one 77. If you remember that particular worker node ending with the 77 working IP having the level of size equal to large, that's why it's got scheduled. There are we can change it, like we can make it prefer instead of soft, we can make it hard by replacing the keyword preferred with the keyword required. And there are also some changes that we need to do. We have the node selector terms, same match key expression, zone, and think we need to apply, because when you create first time you can go with the grade, but from second term onward you need that. Okay, it's much better if we delete that. Okay, let's try once. Making the syntax is must be similar. Okay, then zone operator, yes, everything is, I think, fine. Let's see if error again come. Okay, I have deleted that. Now I have created new one. kubectl get ports -n test. Now you can see that it is in pending state. Why it is in pending state? Because you know well, zone 1 and zone 2, none of there are 2 labels which we mentioned, none of this is present, so that's why we are not getting it scheduled. Same you can check in by describing it to see its events, and you can see that here its scheduling is getting failed. Same like when we are getting in I think we are working on that time on if you remember, at that particular time we are working on node selector. So now we cover the node selector, and we have also covered the node affinity, and I hope you are very much clear with the node selector node affinity concept. If you are clear, then we should move to our next concept. Taint and tolerance concept is very different from node selector and node affinity. What we are doing earlier, we are giving a label, a name to a node, and we are telling that in our file, YAML file, that to particular to go to that node and get deployed over there. And if you're not mentioning it, if you're not mentioning the node selector, there is no problem. No, you will not finding an issue. It will, for example, node A has label and node B don't have label. So it will not affecting the any working. When you scheduling the node without node selector or Affinity, it can be scheduled on any node. But its case when we are using taint, that's the more important. When we are using taint and tolerance, we are using taint when we want to reserve the particular node for particular application. Like I have node A, node B, node C, and node C is a highly computed instance. I am scheduling this for my client's API application, because it's required the highly and I don't want to get scheduled here other application, database and front end others. No application I want there. I want to reserve this node C for particular instance. For example, in node 1 I want to configure all the application here of APIs. So what I can do, I can put a taint over node 2, and when I put taint over node 2, no other pod will get scheduled on here, because if some pod when try to get scheduled here, it will see here is taint and it will never get scheduled here. What is the condition here to get scheduled on node which is having the taint? You need to pass tolerance over there. Like we will see in demo how we pass the tolerance, but on a bigger picture, on bigger overview, like there is a node which have taint, it will not let any application to be there if you can't tolerate it. To tolerate, we need to pass something. It is have a particular syntax, so we can do that. That's a different fact. Okay. Now you can like databases, we want to move some kind of databases over node 2 only. That kind of use case we are having, and that kind of use we are using node taint and tolerance. So how to add taint on particular node? Now in our today's scenario, we are taking the 230 node name, 230 node with getting which having the IP last digit 230. We are adding a taint to this particular node. Is my size equal to large? No schedule. We have a given expression as no schedule. There are other expression are also there. We will discuss for that. We have given taint. What this taint will do? It will not let you to. It's different from levels. It will not let you to schedule your pod, else you don't have tolerance of size equal to large. kubectl create -f, and we are just creating a simple pod. Let's see where it get deployed. I think I have just made some pod, kind pod. Okay. I hope you are seeing this error and you are capable of resolving it. It's just giving us the telling us we have wrongly described or mentioned the object. It's in caps letter pod. There is one more error. Subdomain consists of a error. Okay, now it's okay. Instead of underscore, we should pass hyphen in the name. We can see on which node it gets scheduled. It wouldn't be get scheduled on 172.3.198.230. It should get scheduled on other node, because there we have a taint which yeah, you can see that test port 1, it's get scheduled on 77. So you have the this clarity that whenever a pod without toleration come, it will go to other node which don't have any kind of taint. Okay, so internal, yes, we have added taint to this instance also. Let's see what happened. It's in running state. I think it's not impacted in running state. I just want to check when port gets scheduled already, is state impacted. We can delete and then we will create again. Then I will tell you how to tolerate it. We can use create or apply. Okay, it's in pending state. Why it is in pending state, you know much better. And how you can check that to see its log, this you also know. Warning, had intolerance. Intolerance words was getting very famous a year ago in India. Without, okay, we will just focus on Kubernetes only. So that is the taint. And what is the tolerance? You can see there I have passed a tolerance here which have the effect which will tolerate to effect no schedule with have the key my size and operator equal tolerance in second and value equal to large. Operator is equal and value equal to tolerance in seconds. I think I have done some mistake here. Tolerance in seconds is used when we need to make the port tolerance for some specific time, but we are doing demo in system, we don't need that particular item now. We can discuss it later on. Let's wait, and we need to apply it again. And what you think, it will get scheduled or not? Say yes or no, or you can type. I think you have made your answer. Apply. Okay. Okay. I think I have done a spell mistake. Now it's corrected. We can check our port, test port, one by one running. We can describe it to see its events. Yeah, successfully assigned 230. Both ports are now having the taint. It can be scheduled on any port, any node, because it's have tolerance to tolerate both port. If you have tolerance power, you can be in noisy environment. Some people can't be there, so it depends upon how tolerance you passed. If you see, if we are not passing any operator here, so by default operator it will take equal, and when we not pass effect, it will tolerate all effects, and with the all no schedule and total three we have effect we have. When we not give value, it will tolerate all the values with the size with the key name my size, and when we don't pass key, it will tolerate any taint which you have given. In today's video, we will discussing a problem statement in Kubernetes and how Kubernetes providing solution of it, and how we can apply to it. We will see the theoretical plus demo part. So let's start. I want to give you information. We are making the Kubernetes video in Hindi language, plus we started same in English language, so the people who understand only the English language can connect with us and give us a valuable feedback so that we can improve ourselves. Let's start. So as you know, ports are port lifecycle very short. Whenever something port your service get down, you have to delete the port. You can't reset it. Either you make replica set or deployment. If you something happen, you just have to delete it. Then new port will come up, and your application will came up or not came up. That the other thing. But every time new port will be created, new image will be pulled, and then all configuration will be loaded, and your port will come up. So point is that you have a Prometheus, and you have made Prometheus.yaml, you have put some changes here, and you every time and next time your port get deleted, and that YAML file that you have given, that also get deleted with that port, and new port will create which have default configuration file, that again you have to make changes, and then your monitoring will came up. So to avoid that, what we can do, we can pass this configuration as an config map, so that if your pod get deleted, get down, and when new pods get launched, it have the same configuration. You don't have to do manual changes, and you are seeing these config map. It is a basic config map files which you will see on Kubernetes official doc. It's saying that we are using a kind of config map. This means config map is a Kubernetes object. We are giving this a name, game demo. That's important. We will use this name again in our next manifest file. We are making, there are two ways. Either we can make them environment variable, or we can pass as a file. Here you can see in data we have player initial lives 3, UI properties file name is having the value user interface properties, and after that we are passing the values as a file. Here we have game.properties, and then we are using the pipe sign and entering the value, and enemy.types player.maximum live, and after that we again making a new file, user interface.properties colon pipe color dot good purple, color dot bad yellow, color cloud.text text mode true. So we are defining two files here. One more use case for config map is that when you define the config map, and you see your pod is running. And if you want to do some changes in pod configuration, if you're not using the config map, you have to make the new deployment. But in our case, we don't have to make new deployment, just we change in the config map. And what will happen, we need to delete that pod if it is a replica set. Most probably we are in today we don't use pod directly, we use deployment, and we will delete it, and new pod will came up which have the latest configuration. That's how it's work. So otherwise, what we have to do, we have to do that kubectl apply again deployment. So you are very much clear with that. And why we are making the environment variable when we have to make files, that's totally depend upon your use case, in which client you are working, what its requirement. So let's start. We have made the config map. Now we will use this config map on our pod. You can see that I have given a name to pod, config map demo pod. On that I'm giving the name of the pod, image, command, and env. And I'm saying that I'm giving command to sleep for 3600 seconds, and I'm saying that you should have this environment variable in your pod. Player initial lives, the encapsulator, which will get value from config map key reference. Now you see name is equal to game demo. You remember this name? This name was earlier, if you remember, this name was of our config map. That's, and under that we have the key player initial lives. You remember there have a key player initial lives equal to 3. Second config map we are using here UI properties file name, which is getting value from file config map key reference name game demo key passing UI properties file, and that's having something not remember, you will see later on. That's the first type of use to make environment. Then the second have, we can mount it as a file, as a volume, like I am mounting it under mount path of /config in config folder. We are mounting this, and we are making this read only true. If we are making the read only true, means we read mode is enabled, we can't do any alteration, changes, and modification we can't do. We just read the data. And you can see that volume mounts -name config, and in the name config we have to make the volume of same, because I created the volume for that. Volumes, you can see that name is config, type is config map, for where it's getting the value. Under that we are saying that we have 2 items. Under we have name of that particular config map. Then I'm saying that item, what item is doing, I am creating more than one file. I need to loop the things, then that's why I am using the item. Now item, while using item, how to pass the files, I will pass as an key, then I will pass as a path, like by which name they will create it on the config folder game.properties and user interface.properties. And from where they will get value in the config map, they will get value from a game.properties plus other keys user.interface properties. So let's I hope you are very much clear with these things, what is our requirement and what is our solution, how solution will be done in Kubernetes. That's we just going to check, but more theoretical concept is now clear to you. If you have any doubt, you can write me in the comment, and if you have any suggestion, please write there. Now we are creating a folder demo config. Under that we will create our file config map YAML. And here we will paste our first manifest file. You can give the extension .yml, whatever you like, both represent that this file kind is YAML kind. This is YAML file. We will save it, :wq semicolon, and kubectl, and we can use the create or we can use apply. What I am doing, I am giving the path of my folder. What it make difference? I have to do like kubectl apply -f, then particular file name, and if there are you can take, like, if you have 10 files, if you just give the folder name, 10 file will be applied, and they will applied in the -n namespace. So configmap, config demo is created, plus port configmap is created. Let me correct the namespace. Yeah, that's created. Okay, that's fine, it's created. Ports is in ready and running state, one by one. You can log in the port, because we have to verify the things. We can verify the things once we have the login. So I will show you the result, what we have got. You are also listening from background the local vendor's voice. Sorry for the distraction. cd config, here we will see the files. If you remember, we have used the items loop for making the paths, and yeah, we have created the 2 files here. Now you know very well what is the content inside that particular files that you will apply here. That's the things. You can see values are here inside your pod. Now if you have to make some changes in this file, you can change from outside, and but here we are deployed pod, so you have to delete it and recreate it. So we are in env. There are more environment variable. They are system environment variable. By default they are created when pods get created. Now here you can see that player initials live plus UI properties file name. There are two environment variable are there. They are same available in the env. You can also verify them by doing echo. Yeah, that's one. Actually, I have given I have in the first command I have just copy the whole command. So in space of player initialize comes the 3, and 3 plus equal to 3. You can see that as a type mistake. Now first part is done. In Kubernetes board how to make environment variable, how to use them, and how you can connect them from ConfigMap. Second use case was our we have seen both use cases. Actually we have seen how we can make files, how we can make environment variable. So in case you have a database, maybe MongoDB, Redis, else whatever you have, you if you see they have username, password to connect them, but you can't pass username and password directly there. So what issue comes in passing the username and password directly? That when you pass them directly, they are open to it, because we are just pasting it directly, but you have to use the kind secret here, which provides us the facility to encrypt our username and password. And in username, like you are saying that they are in encrypted form. We do the encryption via base 64 encryption. And kind, you guys can see that kind is the secret and its name database secrets is name of here, and type is opaque. So how first of thing, like your name is Singh, and how you can encrypt it? You can encrypt it via using base 64. Let's see on terminal how you can achieve that. You have to echo, then the string which you want, like that, then bash 64. That's the output you got in an encrypted form. Now if you want to decrypt it, you can decrypt it. If you then you have this output here, and you will echo -n that value / base 64. And if you just do base 64, it will give you again the more encrypted form. To decrypt it, you have to use the flag -" decode or -decode. Yeah, you can see that it's get more encrypted. So if you want its basic form back, you can use decode. You can simply mention the -d there. It's telling us the base 64 encode or decode black. You can see that we have used the -d, and output we get to the point. So that's the example. I just want to show how you can encrypt and decrypt. In the same way, you have encrypted the username, and now you will encrypt the password. Some cases we don't encrypt the username, but mostly we encrypt our username also. You can pass sometime you can pass username in your ConfigMap, but password you can't pass there at no cost. We can keep password as a password only, and that's the output. So here we have username and we have password, and we are ready with our YAML file. So you know very well what we are now going to do. we have made a directory of demo secret. Under we will going to create our secret file. Secret YAML file. You know how to create secret. Whenever you have configuration in the form of YAML file, you just have to kubectl apply or create -f and file name. Plus, if you want to keep it in a separate namespace, then you can mention the name. Here our secrets is get created. You can see the database secrets are created. Now it's the first step, but to use this particular secret, we need some application, we need some pod who is going to use this. You can see that we are using the image Redis by a name of Redis pod, and we are giving a volume mounts in the /etc db certs by a name of db certs. Read-only mode is true, so you can't change the things, you can only read the things. Volume name of db certs, type is secret, and secret name is database secrets. That's the secrets we have created. Now you know what we have to do. We have to make a YAML file for this pod configuration, and we need to apply this. Then we will see what the outcomes, and we are able to access the pods or not. And one more thing, secrets are namespace specific. If you are creating secrets in different namespace, you can't use them in different namespace. If you are creating pod in different namespace other than dev, you can't use them. ConfigMap demo pod is in running state. We have done login into it. Now we will see in the /etc we have certs. I think certs folder is there, db certs. It's not certs, I think it is the db creds, I think. Let's copy it and paste it. Password, username. You can see that they are kind of soft link. Because we mount it as a file, so that's why they are showing like that. We have entered the env variable. We also check that. Creating a new YAML file to use them as an environment variable. In the first type, we have used them as an file path mount. Now we will use them as environment variable. It's giving us the error. Now see its events. What is the issue here? I think there I'm using the Minikube. Maybe that's why it's creating the issue. PHP MySQL app pulling image Redis. We can change the image name here and then we will see. It's not letting me to edit the file. Either we have to use Vim or look for other way to edit this. First, what we will do, we delete this our deployment, what we have deployed, and then we will create the edited one. Kubectl delete -f file and then namespace -n and namespace. Now we make our new YAML file port 4. In that we have just changed the image name and Nginx, and everything will remain same. And let's apply it. You can see the events here. Start the PHP port and successfully pulled image Nginx. In first case it's not getting it, maybe some resource issue. I will fix it later on.
for being the time, I don't have to deploy the PHP application. I just have to demonstrate the secret use. Get ports -n namespace, then we will log in into it, kubectl exec -it, port name, shell, I think namespace was dev, not uit. Here we just have to give env, and we will have our username and password. MySQL, we have two username and password, MySQL user and MySQL password. Where are they? Yeah, that's MySQL user.
Kubernetes, most of our application are objects are stateless. They don't maintain their state. What that mean? When we launch a pod, it do some work, and if there any error occur, it will get deleted and new pod will occur instead of that. It will not get restart at any cost. There is no mechanism to restart the pod. So what is going on? When it's got deleted, it will comes up on maybe on same node or maybe on different node depending upon the resources. So what we can do here, when this pod is getting rated, if it is generating some data, if it is making some logs file, anything which is very useful information for us. So when it get deleted, all the data will also get deleted. It will not persist its state. So like databases and other stuff, we can need to store the data at we can say we need to store data. Plus there is one more case, stateless objects are there which maintain their state. But for example, if there are application like there are 2 or 3 application which use the same reports, same files, and they also write over there and update the data. Like we have 3 pods which contain the 3 different application. All 3 files write the data in a file, and they also read from them and update the data. So if this file is available within only one pod, it will create problem. If that pod got deleted, we can't do work. And second, if we what we can do, we can create persistent volume. When we create the persistent volume, we can do it with the local storage. But what's the issue here? If we use the local storage, our nodes can also get deleted, and it's not necessary we are having the pods on same node which we are again having earlier. It maybe get scheduled to node A, node B, node C, whatever, where the kube scheduler see the resources, and it will schedule there. So what we are doing in the cloud, we have different features out of the box. Like in AWS, Azure, we have some storage services there which are highly available and independent of the Kubernetes lifecycle, like Azure File Share. It is the Azure storage account services under which we can create container, file share, and much stuff. We can create blob storage, ADLS, data lake storage. Many stuffs are there, but for today's use case, we are using the Azure File Share. Azure File Share how we are using, we are using file share as a storage, where we are creating some files, and on those files, on those same persistent volume, we can claim on that persistent volume, we are making a persistent claim, which we are using with the other pods also. So they can also read those files, and can we use that, we can use that data. So we are very much clear with our theoretical part. What is our problem, what is the solution, and what are the cloud component we are using. We have the application which are if we brief this, we have some application who are sharing some files, and they are also writing on it and reading on it. And what we are doing, we are making the persistent volume and persistent volume claim for like in today's case, we are making it on your file share. We have the created playlist for Kubernetes in Hindi language plus English language. Here you can find all these stuffs regarding AKS. First video I uploaded on the monitoring part, how you can monitor your infra using Prometheus, Grafana, and Alert Manager. Then we have logging solution, and we have videos regarding Wazoo, AWS, Azure. You can visit our channel and get benefited. If you have any feedback for us, please feel free to share. And let's start demo for today video. I'm hoping that theory part for being the time is very much clear. So as we are creating persistent volume claim on Azure, we have Azure services. In Azure, we have a storage account services under which we are creating our file share. Here we can put the name Azure storage name. That's also one playlist which we have started of Microsoft Azure. It's now completed. You can watch and share with your friends if you like. Now let's concentrate on our demo. Here we have the subscription of free trial, and we are creating AKS RG resource group. Resource group is a container and a logical boundary under which we can create our Azure resources. We are giving our file share name. We have created a new resource group, file share, to maintain our resource separate. Storage content must be unique. It's a global. Then we have region, under which region we want to create performance. We are just doing it for demo purpose. After this demo, I'm going to delete this, so I don't require the premium. But if you are doing this on your client, you can select the different genre and make it highly available as per your requirement, because your data should be highly available, because data is very critical for today's time for the organization. It can lead to downfall because if your data is not there, you can lose your organization can lose business. Then in advance, we will check. If you want to make it as a data lake storage, you can click on it. How data lake storage is different from blob storage file share, and what are the difference. I have already created a video in Hindi plus English language. You can view that. I will share link on description only. Then we have network, enable public access, enable for prod. You are not supposed to enable the public access. Here I can go with the public access and virtual network and private IP address. and we can restrict it up to a virtual network, and you need to select the virtual network from the below sidebar, or then you can select the subnet also. Okay, let's move to the next section. I hope you are very well clear with the networking. Networking, we have VNet and subnet. They are like in AWS we have VPC subnet. Same the networking we have in Azure. We can do the encryption. We can add the tags. Add tags are always remain optional, but it's good practice to use the tags, and we will review it and then we will create it. In the Azure, whenever we create any services, it will first review it. Whatever the inputs you have given, they are correct or not. It's validate that, and after that, it's created. So let's create it. It will take only few seconds to get created. Now, I've already created a file share by name of file share 1. In this storage account, everything is found under containers file share. Container storage account, we are having container and file share at single place. That is the access key, and using this we will access our file share, because it is not like that anyone can store data. It's not like that bots are just going and save the data. There are some authentication process. They need to be to authenticate with. How we will do authentication, that is the things we need to look for. That we will create secrets for that. As it is we have configured this as private, configured this networking as private, that's why it's not showing. If you change it to public, it will show you the data here. That's the command. Same command you will find on the official doc of Microsoft. We need to create the secrets for Azure file share. After that only we can use it. kubectl is the utility to communicate with the Kubernetes cluster. How to install kubectl? You can same video where we are creating the EKS and AKS. You can go there and watch. That's Azure file share. We have created that secret.
I have already tried a demo earlier, and I have created the secret. I will delete that secret and create a new secret. Now I don't have any secrets for your file share, storage key, and then we will storage. This command, what we do, it copy the key in a variable name storage key. Now storage key will have the value of key which will authenticate with the our Azure file share. And if you see storage account key list up, you need to give your resource group here and your storage account here, and then you will get your you will get the value of the key. Now if you echo the storage key, let's me to echo this, you can see, yes, you can see storage key, yeah, I think some spell mistake. Now I'm getting the value. Now what we need to do, we need to create Azure secret. I will upload a video after this on Azure on Kubernetes secret, some password, keys, and tokens. We don't make them open. We create secret for that, and they will get stored in etcd and make your system more secure, less vulnerable. It's come under good practice to use Azure Kubernetes secrets. What its command is doing, it's generic type creating the secrets for the Azure storage account, and if you paste the command here, yeah, it's saying that the Azure file secret created. Okay, it's get created. Like I have get the value, store the value in storage key. It is in encrypted form, base 64. If you making the secrets by or your own, you should convert it in base 64. So that's our deployment file, which creating the deployment, and that's our first we are making the persistent volume claim, and under which we are giving the name of the file share PV usage file share PV, and creating the claim storage of 10 gig, and giving its modes of read, write, many. Like its mean is simply that many ports can write. If we restrict it to one, then only one user can do the perform these operations. Then we have Azure file, Azure secret file share 1. That's the secret which we have created. We are telling the Kubernetes via this YAML file that to create this persistent volume, you need to authenticate, and to authenticate use these secrets. And it's using these secrets, and with which file share 1 we need to connect, and we are giving making the read only false. If we make the read only true, then we can't write over here, we just read it. But some cases where we need to give access of to read only,
then we need to make it true. Then we are making claim through it. You can see that it is a selector type, which is selecting based on this user file share PV labels, which we have defined. And if you remember, we have defined the same user file share is equal to PV in persistent volume. So automatically it will this claim will go to above PV and create PVC file share PVC, and then we have a kind of pod. We can do deployment, other stuff. That not the main focus of today video. So in that we are creating a volume mount in container specs path. We are giving its name Azure mount path user share nginx HTML, and volumes Azure persistent volume, claim name file share PVC. So in that way we have make this path Azure persistent volume claim name Azure. If you see that volume mounts, we are using the Azure, and in volumes we are giving the same name Azure, and we are saying that this is volume. What kind of this volume is the persistent volume claim, and which claim? File share PVC. So under that we will create those files. So let me to copy this and paste it on our terminal. Colon WQ semicolon and save this, and then what we will do, kubectl create, you can use apply -m name of file. It's created 3 things: volume, claim, then pod, file share PV, file share PVC, and Azure 2. Read write many. That's the file share PVC. It's now bound state, and we can list the pods. Now to check, we exec into it. To log in the pods, we use the exec command -it pod name and sh. What path we have given? We have given /user nginx HTML. So on that path, what we will do, we are at that part. Let me to create a directory. We have file test directory. Okay. So how can we validate that it is getting in the file share? I can't see over there. Let me to change its access. In networking, we have given the private access, not enable. If I can enter my IP, select virtual networks and IP addresses. Okay, enable. If we enable from all network, my network, which is my local, some set dynamic IP was assigned to me by my to my router by ISPs. Then now you can see that here file is created, folder is created, test and file test. Let's check
more thing. We are in under test. We are making another directory. Under test we have created that. Now if we delete this, like it's created the PVC, PV and storage, but our data is still saved. If someone delete the deployment, our data will not get deleted. Let's check. What do you think? It got deleted or not? Yeah, it is got deleted. PVC got deleted, but data it's not get deleted. So if we create the deployment again and some new pod will be created, same data will be remain and it will use this same data. Hope you like the video. In Kubernetes, like in AWS, first I give you the scenario. We have the EC2 instance and we don't want of deletion of this instance by mistake. So what we can do, we can enable the deletion protection on that. So any of my friends which is visiting, instead of making the QA instance termination or dev instance termination, it maybe there a possibility it, by mistake it can do terminate the prod instance. So what we do there, for practice for dev also, we make sure that termination deletion termination protection is enabled, so no one can terminate that instance. So here in the Kubernetes, everything we are just moving on Kubernetes on container environment. What the mechanism or what the solution is offered by the Kubernetes to solve this and to achieve this purpose of to make our application highly available. I am taking the example of an application which have we can assume 3 or 4 node, and to make the application live all the time, we require at least of 2 pods. We can't negotiate up to, we can't let our system to go beyond that. So what we can do, for example, we have example.com on traffic is coming and traffic through, maybe I'll be through ingress, it's coming to that these particular pods. So there might be a possibility your infra provider or the particular zones or particular, we can say, availability zone go down, and your node also can go down. So in that case we can't do. But if there is a planned activity, maybe there is a downtime, there is a, or we have made the instance auto shutdown on 12 p.m. either auto shutdown, or we can say we have made the instance, or maybe there some planned activity from cloud. So your main is your instance, your worker node will got down in that case, but resources are not available to create that pod in the other pod. If we
in the replica set, if we have given the 3 replicas, it will create the same replicas on other node. But in case we don't have resource in other node, the application will not came up, the pod will go down. So what we can, so we will not let the worker node to go down. So what we can do, we are here with the solution with the disruption budget. So what is this disruption budget? It is saying that, oh, you know, who is designing your system or DevOps engineer, you know what is the count of minimum number of ports which are required to make your application live. Maybe out of 2 to make your application web page enable all the time. So you can define minimum available all the time. We will make ensure that these 2 ports will remain live on your worker node. If resources if something resources depreciation or resources shortage will come, we will not let any pod to go down. So this is the Kubernetes object PDB pod disruption budget. You can either define minimum available all the time or maximum unavailable. That's mean you are saying that you have 10 number of ports, and you are saying that if 3 ports go down, I'm okay with that. And both are the scenario in which you maintaining the count of downside, or like you have want to keep at least 2 node or 3 node, 4 node, whatever, 3 ports, sorry, I'm making things, you make the ports number of counts ports to up to a sufficient number. Or you can tell the Kubernetes to, at least if you are doing some activities or your cloud provider is doing some activity, you can make the node down, and you can make our 3 ports or 2 ports down after my whatever ports I have. Okay, so in that way port decision budget will work. I hope you are very much clear with our what is our requirement, why we are comes for this port disruption budget, what was the problem which we are solving with it. So in this screen I'm trying to make things clear by this diagram. We are hosting a website www.example.com on our infra. We have a LB, and this LB is passing on the traffic to 4 different 4 ports of same kind, and these ports at least in today video we are going with the minimum required pod. So at least 2 ports we are required. So that's the manifest file for post disruption budget. Its API is the policy v1, and kind will be remain pod disruption budget. This means pod is an object of Kubernetes, metadata name PDB test, that's just name, and under specification we have minimum available is equal to 2, and we are doing a selector match level run nginx. That's mean you have to keep the pod number 2 of which pods which have the levels of run nginx, which have the levels of keep here run nginx. So any pods which have these levels, it will not let their count to be low than 2. So let's create the post description budget first. I hope this particular manifest file is clear to you. It's just motive and purpose of this creating this Kubernetes files or Kubernetes project to create the port description budget, which will not let the ports to be down, to maintain the ports count at least 2 for all the ports which have the levels run Nginx. Okay, we can list it, verify it's created or not created. You can see here its name have pdb test. You remember we have given the same name in the manifest file, minimum available, and we can also define here maximum unavailable, allowed disruption, age 23 seconds. Okay. It's we have just created it 23 seconds ago. Now we have the other manifest file. In this manifest file we have the apps v1 version, kind is deployment. Okay, let's create it on a terminal. Let's paste it over here. So we have a deployment set. Let's create it. Okay, deployment apps Nginx deploy is created. Now we are ready with the kubectl pods. We have the Nginx deployment 3 pods. Here I'm explaining this particular manifest file. We are using deployment, and under that we have given the levels run Nginx. That's level is very important. You know that's important. And if you not getting it, the levels, how we can assign, what are the level importance, you can go to section video in which we have levels in selector, and then we have replicas equal to 3, selector match level run Nginx template. We are using the run Nginx specs. Under specs container we are using the image Nginx, and we are, as we are using replicas is equal to 3, we have the 3 ports of our Nginx. I am doing this on AKS cluster. So either you configure it on AKS or on EKS, it will not going to affect much. So I currently I have only one node. Actually one node will help you in that, because if we have 2 nodes, the resources will get shifted on other node. So what we will do, we will it is saying that unable to drain node AKS due to a node port ready to override. Okay, we have to override as to override we have to pass this particular parameter -, read empty directory, because it's have empty directory available there. Now you can see the logs. It is evacuating the ports, and it's saying that error, it's getting error to evacuating the ports, because it have the port description but budget live there, so it can't do that, because port description will not let to train the node. If we can assume that if we not configure the PDB, all the resources will get evicted, and ports count will becomes to 0. If we kubectl gets node we have done, and we can see that we our node in ready, but scheduling disabled. We can't schedule for, like I want to deploy a new port, we can't deploy because scheduling is got disabled, so schedule can't deploy. Here you can check first Nginx port is in pending, go in pending state. First it was in a ready state. This was happened 71 seconds ago when we drain the node. Is it easily remove this port, but it was unable to remove those pending 2 ports because they have the disruption budget. And you can see timing 3 minutes 59 seconds when we have created that just 4 minutes ago. Now if we have to make the application back live again with the 3 ports, we have to untrain the node and make it available for scheduling, because normal ports can't be scheduled over this scheduling disabled nodes. Or we have a second option to launch new worker node. We have to scale it out, but for today video, first purpose of giving you the hint of PDB, how PDB work, I have shown to you. Now I have to uncode the node. I will type here kubectl uncodon, and I have to give the name of the node. Here we have the name of the node. I will paste it over there. And it's uncoded. What will be happen by this command? We will check it by kubectl get nodes. Yeah, you can see that it is in ready, and we are now can schedule more application, more ports on these node. If we do kubectl get ports, what will be happen? Our 3 ports will came live. How it's came live? Because 2 ports are also live, and 1 port was gone dead because of the resources not available. Ports not gone in draining state, and when nodes came up for scheduling, our 3rd port it's also came. You can see in my screen there is some traffic is coming. We can assume that it is a website and maybe some application or any sites. Traffic is coming, and through LB plus Ingress, traffic is shifted or routed to different ports. These ports I have maybe contain the same application or maybe contain different paths. We can see that this part is /blog, about us, home tab, the different kind of stuff is available. So if one pod is get failed or application inside the pod get failed, what we can do? So if we assume that our application is running in instance, and if application goes down, we can do monitoring over that, and we have to deploy, we have to resolve that error. And there is no option that instead of that new VM will launched, we have to fix that, and we can make the auto scaling. But how to fix that? Someone need to log in and fix that, or remove that particular VM. But in case of Kubernetes, we have some advantages, some solution which are out of the box, which are not possible in very difficult to achieve in VM structure. Like, we have a pod. If application inside the pod is failing, so it can restart the pod. That means restart refers to deleting the pod and creating new pod. For that, we use the props to check the health of the applications. Application health is determined by the props. We have different props. First prop, we have the liveness prop. Liveness props is the only prop which can restart your pod. For example, if application inside pod got failed, and there must be a health check which is configured by your developer team, and they will provide to you. Upon on that particular health check, you will hit API every time. Frequency is set by you, and whenever this response we not get response, according to the action will be taken. And with that probe, we have second probe, readiness probe. It's check the pod is ready to accept the traffic or not. Like if pod is not ready for the traffic, to hold the traffic, it will not add in the ingress pod or LB target group. In AWS we have target groups, uh, so it will not add in the target group, for example. So it scan means you have two pods of same application. Third pod is going to auto scale because of the increase in traffic, but it will take some time. And once it is ready for the traffic, readiness probe give it's a green signal. And it's more about the readiness. It can't restart your pod. You are not able to restart the pod. To restart it, you have to configure the liveness probe. So third condition is coming here. One more probe we have. There are some pods, some application which are using the much resources and they are heavy application. They take some time. For that we have this startup probe. Startup probe what does? It disable the both liveness probe and readiness probe for particular time up to which startup probe will work. Startup probe we configure only then where we have some kind of application and we don't want port restart, because it is going to take some time. And if liveness probe failed in that particular period, it will restart your port and your application will go in a problem and it never come up. So I hope you are you have understand the why we use probes, what are probes, and what are the major types of probes in Kubernetes and what they are work in, we can say, in theoretical way. So it is I think it's video number 7 for us. We have not covered the LB and ingress. We will do in later part of video. For today video, just understand that LB is a load balancer which maintain the loads, load of the traffic, which maintain the load, it will distribute your load on your pod of same type. If you go to official website of the kubernetes.io, you will find the section for props. Before going to start the demo, I will like to show the content of my channel. We have videos on Azure, AWS, Wazoo, and different stuff is over there. Kubernetes in Hindi and English language both are there. You can visit our channel, and if you have any feedback, please share with us. And if someone is reading Kubernetes, and you can share the video with him. Hopefully, he will get benefited from our videos. So let's start today demo. That's our first file. We are going to configure the liveness prod. What this file is doing, it is simple manifest file. You will find this file or this particular example on Kubernetes official doc. So we are creating a kind of pod and giving its a label, and it is just giving its name liveness exact, and its specification, we are giving the name and image. It is using the public image of PVC box, and we are passing the arguments. What in the argument we are passing, we are giving it as a shell /bin/sh, and then -c. We are providing the commands which we are saying the touch /temp/healthy. That's it will create a healthy file in /temp, and then it will go in sleep mode for 30 seconds, and after that it will read that file. Okay, it is a simple Linux command which is creating the file, making your system to sleep, and then uh, deleting that particular file. On that, we are creating the Liveness Pro, and what is it's doing? It's doing cat or reading that file. It's doing cat the particular file. When we do the cat to particular file to read the content of the file, if this file should be present over there. If file is not present there, you will have issue, and your command will fail and you got error. So we are passing here two parameter: initial delay second and period seconds 5. So whenever we launch the pod, it will wait for first 5 seconds, and then it will launch. Then it after that 5 second means a total of 10 second. After total of 10 second, it will check the first probe, and with the frequency of 5 second, it will continuously check the Liveness probe. So I hope you are very much clear with the manifest file of Liveness probe. Let's create this object of pod with Liveness probe. You know very well how we can create the objects, and we are creating this under particular namespace. So our pod is created. Let's kubectl get pods and check its status. We have to pass the namespaces with it. Yeah, you can see the Liveness exact pod is in a ready state and status is running. How we can check the events? We can use describe. It will very help you to understand, like kubectl describe pods Liveness exact -n test. You can see that it's successfully assigned this particular node to installation pod. Then it's pulled the image and created Liveness and started container. Now you can check that it's after 30 seconds it's giving that 30 to 37 seconds it in a good position, and after that after 30 seconds which Liveness probe check happened, it found that file is not there, so it got failed. What we have given arguments and instruction in our manifest file according to that, and what we have studied earlier, Liveness probe, if pod application got failed, its health check got failed, it will restart the pod, and you can see that Liveness probe got failed, then container Liveness probe will be restarted. If it is restarted, pod restart just mean pod got deleted and new pod will get created. You can see that it's again pull the image and create the container and start the container, and successfully pulled image and container is in a running condition. So all the events which are occurring, either you can exect it. Meanwhile, we will check the pods. Now you can see that it is in 1 by 1 state, that it is in ready state, but you can see the restart one. It's get restarted 59 seconds ago, and you will find every 30 second 30 or 35 second it will got fail, and whenever it got fail, Liveness probe will make it to restart. In that way we can make our application healthy by using the Liveness probe. Means you have a Java application of your website, and it will got failed due to some, and you configure some HTTP endpoint over there, health check point over there, and your Liveness probe continuously ping it, and whenever ping response got failed and not come, it will just restart your I think it is just restart your container, means you will create new pod, and on your pod new container will create it and your application will come live again. So that was the case of simple demonstration of Liveness Pro with the using simple Linux commands. Now we can move to other props, and we can configure here the Liveness prop of HTTP of kind. It's we can most of the cases you have some HTTP or HTTPS application. How you can configure the health prop there, that we will see. That's Liveness prop HTTP get we are using. We are giving its path /health. That /health path will be given to you by your organization team, developer team will configure that particular health prop. You don't have much to worry about that. They have to configure that to make their application manageable. And you can see that we are giving a port 8080, and if I tell you more what it's doing, it's using a function under that we have a function of /health. For first 10 seconds it will work fine. It will give you response of 200, which is a good response, and the application will become live. And after that it will going to give you the bad response, which make your application lead to down. 200 to 300, your status code when it's coming, it's considered as a good status code, but whenever it's go above that, and it will consider as a bad response, and we can assume that your application is got down. So whenever your application is got down because of any reason, the first task is the automation, that it's get fault get replaced and your application will be again live. So let's create this particular object and check what its status. I hope font is not the issue. Font is very much clear to you. kubectl create -f. That's if you do kubectl get port -n test, yeah, you can see that here Liveness HTTP is ready and running state, and there is a no restart. Initial delay second is 3, and after this 3, after all 3 seconds it will do Liveness check. So we can make it's describe it, we will describe it for better understanding. It will take restart much frequent than a previous one. I think, yeah, describe pod, we have to mention which kind of object it is. That here you can check 64 seconds successfully pulled the image, created the container, started the container, then successfully pulled image again, pulling image Liveness because of the Liveness probe failed with the status code 500, that one, because whenever it got the response code with bad reputation, it will consider your application down and restart your pod or container. If you see here, it had taken 3 times restart. Sorry, it's taking restart because it's getting failed over 10 seconds. Earlier we have if you remember, earlier we have the timing of 30 seconds. Now in the TCP liveness YAML we have we will actually video is getting lengthy over here, so in this particular YAML file we are going to implement all the three use case: liveness, readiness and startup pro. If you can see that uh, we are having a geo proxy image which is a public image, and we are checking its TCP connection. It will listen on 8080. Readiness port, we have given the port 8080 with initial delay 5 seconds, and after that with the interval of 10 seconds it will check for readiness probe. Same we are doing for liveness probe. In the Liveness Pro we are giving the same TCP socket because container port is the 8080 only, and initial delay second is 5, and same per second health check is 10 second. Status Pro TCP socket, here is the port will remain same 8080 with initial delay second 30 and period seconds 20. So what we are doing him 30 second, actually uh, it will wait for your application or your port to came up, because there are some certain cases like you have a very heavy application which take time to load, and if it takes some time, maybe take much time because of any issue due to slow internet or any other issue, it will not let to restart or failed your pod. So we are giving the sufficient time of 30 seconds, and this time may vary according to your application or your use case, what kind of application you have and how much time it take. That's your particular use case, you have to take care of that, what time your application can take up to, and after what time you are going to check that. So whenever when it's came up, if you see that its time is 30 seconds and others time is 5 seconds, but others times readiness probe time start when it's came up and its 30 seconds are gone, are completed, not gone, are completed. After that it can take, you can see that after the near about 45 seconds it's given us the ready status. um, Before that it not given us the status because of the particular startup probe. That is the use case of the startup probe. If we describe the pod, let's describe, because in the particular case our container is listening on 8080, so no probe will be no probe will be no probe will have issue and our container will not get restarted. To check our probes they are working properly, we have to play around them, make some changes to observe the result, to find the differentiate what is going on. So first we delete our current current objects, and we can create our. So we just focus on our two profs, liveness and readiness, how they are working. uh, in earlier they have given the status around 45 seconds. Now you can see I have just commented out the startup row. Now you can see it given us the ready status within 15 seconds, because we have initial delay of 5 and after that 10 duration of 10 seconds it checks for probes. So that's why under 15 seconds it's given us the result of working. That's your containers are working. So that's the first thing I want to show you. Now what I have done, I have made the port down like it's I have set it on 8081. So we are not going because image is not listening, container is not listening on 8081 port, your props will get failed. So let's see uh, what happened. Yeah, it's created. 8 seconds are gone and it's showing us the result of that in 0 by 1 second. It's okay. Now we are describe it. Now we are here, successfully assigned, okay, container bold image, and after 20 seconds it's got failed. It's saying that the readiness probe failed. After that our liveness probe will also fail. And you know very well that when liveness got failed, what will happen? It restart the pod. Let's kubectl list the pods in the test namespace. You can see here we are seeing that liveness and readiness both got failed and our pod got restart 29 seconds ago. If we delete the, I think it is clear to you. Let's delete the liveness, these particular objects, and we correct the liveness probe. We are just doing this stuff to make you observe or to experience the difference. Now let's create it. Create -f tcp liveness.yaml. Now see, we will do the list of pods. They are not in the ready state. It will take around initial of starter probe time. After that it will check for health. So our only probe which will got failed this time is the readiness. Yeah, readiness probe is got failed, but if you list the pod, you will see it's not taking the restart. So that is the for today. Managing secrets in Kubernetes is become pain when you are not using any secret manager. Your applications must have some secrets, like your external DB. You might be you are using the we can say cloud managed Postgres or cloud managed SQL DB, RDS. Whatever you're using, they have some user and password. You can manage them via Kubernetes object named as Kubernetes Secrets. But currently time we use VCS for everything to make versioning and all this stuff. So your Kubernetes secret manifest file will be get uploaded or get pushed to the your VCS, but it can be decoded easily by anyone which have access to VCS, as basic 64 decoding is very easy to do. For that we have some options. We have secret manager in cloud wise. Like in AWS, we have AWS Secret Manager. In Azure, we have KeyVault, third party, very famous tool, Hardship of Vault is there. So instead of making secrets in the Kubernetes cluster, we save our we can save our secrets like user equal to admin and password is equal to @#123 into our secret manager. In my example, in my demo, I'm taking the example of Azure Cloud, and here we have the service KeyVault, and under that I stored the user and password as key pair form, and from there, via using secret store crat secrets object, we are authenticating the external secret. External secret is authenticated with the KeyVault via using this key secret store, and when it's get authenticated, external secret automatically create Kubernetes object. Things will automatically get created, and it will remain synced with the KeyVault or whatever hardship of Vault or AWS Secret Manager, whatever you are using. They will remain in sync, and whenever means currently your password is @#123, and after some time you have changed it @324. You don't have to come to Kubernetes, you just change it at KeyVault or your other manager, and after that it will automatically get refreshed, or its value automatically get updated here. So we don't have to manually create our secrets, don't have to put it in VCS. It will safely remain here. And under KeyVault, we have access policies. By using these access policies, we can control the access, and whoever the person is be like only 2% X and Y are required to access the, but must have only have the access to these creds. The only they will have, others they will never get the access until the admin provided. And like VCS, here we have the provisioning. One thing like provisioning and versioning also, like @#123 was my previous password, and @#321 is my new password. Under that KeyVault, we will remain, there will remain the information about both until we will delete the version. And under version 1 we will have @#123, and under version 2 we will have @#321. So I hope flow is very much clear. We are saving these secrets in KeyVault instead of making these secrets via manifest at Kubernetes secret. And from KeyVault we have some authentication method, like here we will use service principal. Okay, and from the service principal, secret store is validating, and through this secret store authentication, external secret is creating these secrets in Kubernetes environment and in your namespaces. And also when it's creating the Kubernetes secrets, it's also managing them, like refreshing them after a certain period of whatever you select. For example, 1 hour, and 1 second can be possible. Whatever you can put whatever you want. So in that way, you this is the high level. How we do, we will see now. Here is a quick intro to my channel. We create the videos related to DevOps, like Kubernetes security tool, SI monitoring, logging. If you can visit our channel and get benefited, and if you have any suggestion, please comment. Okay, let's look for the demo. For the demo, first things we need require is the Kubernetes cluster, and here we have already ARG, and under my free tile, under this particular RG, I'm creating this KeyVault tap on target. under my region Central India, and pricing tier is standard, and recovery option, softly data session, the vault, and path protection. Then we have access configuration. Access configuration is your role-based access control. We can select it to vault access policy. Whatever you desire, you can change from here. Enable public access currently is it enabled, but if you are moving in your working environment, as I will delete it after this demo, but if you are making it happen in your environment, please go with the non-public access. And we can go for the review and create. It's reviewed. Let's create it. Okay, see, KeyVault is getting created. We under that object, you can see we have secret certificate keys. It's give us the option to store. For being the time, we will create a secret manual certificate. Oh, what was second certificate? Okay, we can see key, and the value is demo is successful. One second, demo is successful. Give the value to it. Enabled yes. Okay, let's create it. Demo is successful. Okay. First step, KeyVault. First dependency of this task, KeyVault with secret is created. Now we will move to next part. You have to search for the app registration service. When you search for it, it will create a you will get this type of window. Then you have to create new registration, and we can say name it a external secret app. Account is only DNet. Let's create it. Okay, it's get created. Under that, your app you need is secret ID to be deal with. Okay, let's give a name, description, ext secret. Okay, we have first one is ID, then second one is the value. That's the ID and that is the value. We will use them. Okay, now we have our app registration ready with our client ID, client secret ready. Come back to the KeyVault, and under KeyVault you have access policies in the left hand side. Go to create, and being that I am giving all the condition, all the permissions, and then choose next. And under principal you can see that we have external app principal. Then this one we have just created. We are in this way we are giving permissions to this client ID, this application, to access the all the we have done like secret certs and keys, all the three services permission: read, write, and anything to this. Okay, here you can see that ext secret app is getting created, cat list create, and secret permissions. Here we have done most of the things. Here you can see that we have application ID. We require this value also. This was our client ID and its secret. Currently I'm using a free trial account. It will be get deleted in 1 or 2 days, so don't try it. Okay, that is our client ID and the secret value which we have generated. Okay, we have now move to the cluster implementation part. Create NS test. Everything we will do in a separate namespace test. And first thing which we need to do is Azure secret. We have to create for this client ID and client secret. Okay, cool. Here we have to pass the namespace. Okay, it's created. kubectl get secret -n test. Now we are hoping that we are ready to authenticate. We have something to authenticate with the KeyVault. Now come here. We require two files. First is the secret store and second one is the first one is the secret store file. It's have some API version external secret.io v1 and secret store. Then we have Azure backends. Under that spec we have provided Azure KeyVault. Here we have to provide our TNet ID. Then we have Vault URL, client ID, and secret store creds. After that, secret store creds will remain same. Under that we have client secret as we can say as the value pair. In that we need to change this. Here we have created the secret Azure secret SP. And under that key is also different keys. Okay, client ID, second key is also different. Sorry. Okay, and let me add the URL. Then here we will have to pass the TNet and then we have to apply it. Here apply kubectl apply -f. Sorry, we are at different folder. We will apply it here. kubectl apply -f secret store -n-test. Okay, it's saying that resource mapping not found. Your backend. okay, external secret IO figure beta 1. Actually, there is one more step. We forget that. Before applying it, we require external secrets there. Otherwise, this step will fail. This step, this particular step is doing. First, I kubectl get of test. Currently, there are no resource there. Let me add this repo and my external -test. It will create external secret release and some ports of it. These ports are required. These are working as a CRD for secret store, this particular API version, and for external secret API version. Plus, they are providing the functionality to work and the resources. Some resources are required to give the boosting and give like backend for the external secret. The external secret we will create, and it's kind of their backend type, we can say. Okay, they are all up and running, and now we can test our file again. Okay, now it's get created. Okay, now kubectl get secret store -s test. That's what is the status. Manifest get applied, and we have read-write capabilities, and ready state is true. So now we can move to the next is external secret. Name ext and namespace is test. External secrets will actually we can have secrets in hundreds, and I don't might be require all the 100 secrets in this test namespace. Might be require 10 only or 20 only. So how we can do that? How we can manage? How we can fetch this? How there is should be a way to tell him to fetch the particular secrets. And here is the name external secret namespace test, and after what time it will refresh. The secret value is 1 hour, and secret store reference is, it's not cluster secret store, it is secret store, and secret store, and it's Azure backend. It is Azure backend. Under target, it's in the this is the existing, and I want demo secret target. In the target we mention what we want to create or what we want to refresh or achieve. Secret key and remote key reference. Okay, here we have key and remote reference key. Secret key, we can say that is demo key. Okay, and if we finish this file, it's saying this API version we have to use, and we have to create an object named as external secret, and ext, this name is will be external ext is okay, and under namespace it will get 1 hour refresher time, And secret store, it will look at taking reference from this secret store, and this is the name of that particular secret store, and it will create a Kubernetes secret by name of demo secret, and under that it will create a demo key, and whatever the value was there it will put here, and key which it's looking at is this. It's the key which is looking okay. I think it's okay. kubectl apply -f external secret -test. Okay, it's also get created. Now if you get into whatever the external secret we have in the test namespace, here you can see that we have a external namespace via name of ext, and under that we have Azure, which is taken reference the Azure backend, the secret store we have, and it refresher time is 1 hour. Its status secrets are synced, and it's ready. So let's check quickly it's created a secret or not. If you remember, this secret we have created, and this demo secret what we require, and this external webhook, and this is the release which we have created. Let's see what is under that. Here you can check that we have listed its YAML file, and version is v1. Demo key is available there, and from where demo key is coming from here. If I paste just key here, it will comes the key here, but the main question is that is the value comes, and if you remember what was our secret is demo is successful, is come here or not. Main question is that. So if you just click over here and copy it, and echo this secret base 64-d. Yes, it's fetched it. Demo is successful. So our flow, what we have targeted for today, is completed. From KeyVault, we have created a KeyVault, make some authentication method, and through service principal and fetched it. We have put a secret, and we have created this secrets in Kubernetes, and which is continuous in synced with the KeyVault, and after 1 hour it will get updated. So other query now, like you have application which is which can point to this Kubernetes secret, and it will fetch. Hello everyone, I welcome you all in today's video. Hope all of you are doing well, and this video is going to be a demo project on our Kubernetes cluster, and I am taking AKS cluster for today demo. And you can see a picture in your screen. This is the architecture diagram of what our infrastructure or what our project will look like. We have a databases, we have a middlewares, gateways, and web servers in our projects. So by implementing this project, you will get a very good hands-on on and good knowledge of Kubernetes, and a good hands-on for projects. You will get the we can say the practical aspect, what you should require when you are implementing or creating project, how you can deal, what are the requirements you are look for. So I hope this intro looks interesting to you, and let's start for today video. And before moving, I like to give you the introduction of my channel. I make the video related to DevOps, and there are multiple playlists you can find on our channel. Wazoo and is getting very popular. You can visit our channel and get benefit from that. Let's start. This is the different playlist you can see on our channel. There are multiple, and we have covered the multiple deployment, multiple things. Let's come back. Okay, we have a Kubernetes cluster on which I have two node currently. For being the time, it is perfect. If you require more as per the requirement of application, we will launch more. We can say more tools, more node we can launch at that time. Let's start here. We will copy this project. We will clone into our local environment, and it is a public repository, so you can also. It is a. I found this repository on internet and found this very interesting for the demo purpose, and everything they like database, middleware, everything we have there. So if we come back again to project, we have two databases, two storage here, MySQL and Elasticsearch. Both we deploy on the Kubernetes cluster, and while we start any infra, any project, first we start with the databases where we plan everything, but for implementation, we start with the things which has no dependency. Like this web server is dependent on gateway, and gateway is dependent on this, and these middlewares are dependent on this particular Elasticsearch and this MySQL databases. So we have done the cloning, and this is what we get. So first we see MySQL, what is this, and how we can achieve this. Here you can see we are making a deployment, and it's kind of V1 version, and EMPS DB we are giving its name, and there is no namespace metadata. We can choose spec. We want to create one replica. For today demo, we are just going with the one replica, not creating a high level, and we can go with the managed services. For being the time, we just create one replica and make it on Kubernetes. So under that we have we are taking a image of EMPS DB, okay, and then image pull policy always EMPS DB, and container port is 3306. Limit is set. We should always set limits and request to our all the applications. They are just here they are just mentioning some environment variable. Anything which you like to pass, you can pass. And here I can see there is no authentication is currently set here. Okay, no issue. We have a service v1 EMPS DB. Okay, 1 second. Here I am seeing their repository EMPS DB, and if I go to tag section, I'm seeing tag 1.0, its latest publish, and here is 0.1 tag 4 years ago. Okay, so both tag we have. We can make our own. They are building this file, this image from official Microsoft image 5.6 and adding a MySQL root password and let's go with it. Create our first let's create a namespace kubectl create ns. We can say test. Okay, test is created for visualization. I'm using lens and test is there. Okay, currently nothing is there. Okay, just here we are in the project. Under that we have cloned the directory. Just move under that and we have MySQL. Okay, create .yaml. Okay, so let's apply this simple Kubernetes file kubectl apply -f and then we have k8s.yaml -n test. Might be command not visible too. I think now it is visible. I have use the command kubectl apply -f k8s -n test. Then through this we have created deployment and one service, and here you can check we have two we have requested for two Kubernetes objects. One is services and one is deployment. Let's come back to Lens. Here you can see our one deployment with one replica set, which in result giving us the one pod is ready and it's running. We can check its logs. So there is no looking any error. And but as I'm seeing, it's continuously taking restart, and when I'm checking its logs, unable to start server, and this entry bar is getting killed waiting for server startup. We can do one thing. Here if you check again, we was just using the official Docker file. Under that we have MySQL 5.6. Same we can call here. Okay, just we need to comment this. And let's check. Doing the deployment again. EMPSDB configured. What I have done, I have changed the configuration. Like I'm changing the image from which it's getting fetched. Might be the issue was the image. We are at length. Let me go back to overview. Okay, you need to specify one of this following: my root password, or MySQL allow empty password. Okay, let's do this. Okay, it's working now. Issue was that the specified memory was not sufficient. Here I have raised it to make it double for being the time. It's can increase its limits. For here we see if I go back, but we have used this, so this image is not having any issue, so we can use their image only for being the time. Check with it, it's throwing error or not. It shouldn't throw the error as we have increased the limits. First we check it's throwing error or not. Okay, it's new pod. Let's check its logs. Okay, it's working fine. So we are ready with the first our microservice, and it's one of our database. And while we work with the database, we should provision the PVC and PVC claims. And if you watch my previous videos and where we deploy the Elasticsearch and other stuff, we created the PV. For being the time, we are just creating a demo for the application working. Our is main focus. Then the this is the must-do part. We will cover it later on. If we just close this and go to second part is the Elasticsearch, and under the Elasticsearch, what we are having Elasticsearch file of 7.5.0. It is a particular Elasticsearch version of 7.5.0, and it's have some Elasticsearch heap value, how many value it will take, and its password, Elasticsearch password, and Elasticsearch.yaml. The configuration we are passing from our local to under that user share Elasticsearch.yaml. If you see under Elasticsearch.yaml, what we have, it is a very simple Elasticsearch file which have the cluster name via OT microservice, and network host is open to everyone, and it is single node and discovery and expect license type trial, express to OT enabled. Okay, and monitoring collection also enabled. So if security is enabled here, we should pass the authentication here. And remember the default password was the password, and we have override this password we should use the Kubernetes secrets or secret through KeyVault and other key services. You will find a video on our channel for this particular secret management. For being the time, we can let it as it is, don't push it to the git. And after that we have created YAML. We are creating a deployment same as EKS ES, and it's using the OPST version of EKS ES. It's mentioning the deploy time. Here we are mentioning the deploy time, but where we are giving the password. One second, we are not on the Docker file. Okay, we have given password, and root user is by default is Elastic. So we this file is look also complete. We don't need much to do here. So we just come back to what we can do. cd to Elasticsearch and kubectl, apply -f, and it's again kits.yaml, and in the namespace test we are so we have run a new. In that particular ES, we haven't defined any, if you can see, we haven't defined any resource limit. So defining resources is very crucial part, and it's taking 466 MIB currently, and the CPU, very low CPU it's taking. And check its log, what its log saying. Okay, well, EMPS TB, EMPS ES, sorry. It's cluster info, SMP service, cluster motive microservice, EMPS EB message, cluster UID. It's standalone, and OT microservice EMPS. Okay, it's also loaded and working. So till now we have two components in place and they are working. One thing I want to say, if we are creating here the deployment, but when you create, if you want production level setup, you use this block of Elasticsearch. It will give you a high level of Elasticsearch cluster and highly available cluster with I think 3 master you can create, or whatever the requirement you have, you can go with it. Moreover, if you want to learn about the PVC and stateful set, you watch these videos and how to deploy stateful set with the persistent view, you can go with it. So we can move ahead with the third services. If we look back again to this, now we have in place these, and we can go with this one, employee one, and employee, come back here, what it's saying, employee, they have config for it, and elastic, some elastic packages it is using. So employee they are creating, and if we see, employee is talking with Elasticsearch and gateway is talking with employee. Okay, just come back, and here we have the Elasticsearch config to employee config, it's Elasticsearch username, password, and API port. It's port of this particular service, and 9200 is running. It's Docker file of solution. Okay, it's copying this folder and making it a working directory, then it's running the Go deployment. This particular application or middleware is made from Go language, and to build this we are running this command, and this is the example of the multi-staging Docker file, and under the step we are making a build, and then we are taking a alpine image, very light image, and making a we are making a statement that take this /app as a working directory, and we are adding some dependency over here, and then we are making a copy from builder is here. We are making copying for builder under the go as RC employee. That was the previous working directory. Under that we have a there should be a, like we can say, binary file which come as a output of this build process, and we want to copy over here. And config.yaml in the slash app we want this config, and config file is placed here. Okay, we made an environment variable of a config file here. So if we not made this, we have to pass here the config file with path. Currently with non-date, we just are good with this to start the application. So expose as this is available to others at 8083. So Docker file, after the Docker file the things come is the not Jenkins files. Here with the deployment of EMPS employee, and it's making, I don't think this image will work. It's like some private images. Okay, deploy container port, and like here you have made your Docker container working at 8083. You should, and while you deploy it on as a Kubernetes pod, you have to make it expose on your container port will be exposed, but you have to make it explicitly mentioned in the ports of pod. So 8083 will be available to other ports for the communication. Okay, just get it one step back and go to employee ls. One second, we are here. EMPS. Just go back. EMPS DB Kafka salary. We are looking for the /e MPS employee. Okay, employee is not there. Now we have this image. I don't we can check we can use this image or not. We have tag 3.0 and we all the apps previous we have used of old version, so let's use this app only for the being the time. Okay, and kubectl deploy -ks and test, and in employee we can go with it. So it is created. This as per me this doesn't have much meaning. This just to make example of environment how we can define. So EMPS is also there, so we can see EMPS image pack pull off. Okay, we have deployment there, we have pods there. Actually, we have done a mistake. We have just copied this EMPS 1.0, not off string. We should mention the full address, registry, and then image with tag. So if I came back to here, I change it to off string EMPS employee, and now if I can go to lens again, I'm seeing this is working. Let's check its logs again. Listening on, and it's starting listening on 8083. So what we can do, first get a taste of the application, that we are getting it right or not, if we have gateway or not. What is under gateway? Let's see. Gateways look like a load balancing services, and as per the request, it's spreading the request. And how is this code? Gateway and gateway docker file. Maven, using the Maven latest as a builder, and object solution is maintained. Then this Java repository, we are copying everything, each and everything under a Java directory, and making the Java directory as our working directory. Then we do a run Maven package. Again, this is a multi-staging Docker file, and through this we get a binary in Java. We can say it's a jar file. It might be a jar file, and then from Alpine, a very light image we are taking, and user, through root user, we are making this dependency to be installed on the Alpine image. And then we are from builder is the above stage. Here we are taking the Java target. Under that Java we have a target. When you run this particular Maven command, target repository will get created, and under that you will see gateway service.yar, and this we are getting copying to /app. And while we are making this copy, we are also renaming this gateway service.jar to gateway.jar. So /user/bin Java. Then we have its gates file. Again, one more deployment. Metadata are there, some specification, how many replicas, and what is the strategies. Again, a private image is looking. Either we can create our own image with this Docker file, or we can use their. For the other service, which we first test the application, then we will create our own application. Just check with them, they have their service or not. Yes, is available there. And for all the services, the tags, we have taken the very old tag. There are two tags old. Let's take this. It might have some or not. If it is not work, then we will go with the older one. Image is the. Then for the communication we have service, and it's also cluster IP. Then we have AMPS gateway. Then we have TC protocol, and this has the 8080 port. And same we can see container port is 8080 plus in the Docker file. It's also making its container exposed at this port. If we see, if we go back again to CD gateway, gateway is getting deployed, I think. Once again, I think again we made a mistake, and this time you know very well what mistake we have made. We have again choose the improper image. Here we are creating the deployment. One beautiful thing about the deployment is that, like here, you can check first new image will come. If it's came up, then the older one will get created. Before it, if others is not coming up, next will not get created. So EMPS gateway is also get created, and if we can check logs, we have a logs and it's reading 8080. So the next component which we have is the web server, and web server is connected with the front end. Okay, so what should we do? We should create first we can create the web server and front end. Let's create the front end first, because without the front end we can't get the taste of the application. Front end, here is our front end, and if we see, I want to thanks the organization for this public repository and that beautiful demo, and everything they are copy in. Okay, it's a I think Node application, and everything we are copying in this slash app, then it is it will act as our working directory. Some we are installing here git and npm install, npm run build, then the yarn add serve to build this, and exposing we are on 5000 port. Okay, and after that here port is 5000, and after that here if I check EMPS front end, then I go here. They are the public images. You can also use and create your own images. EMPS front end, Obstree EMPS front end. There are some users which also created this. Might be they are their company's employee or what. So Obstree EMPS older version, 4 years ago. Okay, let's go with the 1.0 version only. Then okay, that's one done. CD back to it is front end, and kubectl apply command -n test. Till the time it's getting deployed, show us the log. We will check for the web server. Where is the web server? This is the web server, and here is the Docker file, and this is just simple Nginx file, Nginx image of latest kind, and we are copying some configuration to the etc nginx.conf. Okay, then we have if we check this etc nginx.conf, where is it is this is the nginx.conf. So user root, work processor, auto, PID is this, error, okay, 2048, HTTP, sender on type JSON server, EMPS front end on 5000. Some kind of reverse proxy is this working here, and if you can see, the request is on port 80 will be getting redirected to the front end, and you have seen that front end was exposed at 5000 port, and after that, if someone is looking for this /attendance one, if someone looking for the attendance, then it is going for the attendance which we have not deployed yet, and employee, and then it's going to the employee service. It means we haven't deployed the salaries and the other one, and this will not will get resolved, but employee one will get resolved, I think so. And then location of health jet access log. Okay, front end, we check the front end logs first. Front end is there, and is it healthy? What is log say? Accepting connection. Okay, it's accepting connection. That's good for us. Okay, then we have web server. Under the web server, we can just simply apply the files. Here we get the error, the path don't exist. Okay, here we have checked in the web server only, we don't have any KX file, so we have to create our own KX files. We have front end. Just go to the front end and copy its files. Just paste it over here, and here we have the API version, apps v1 deployment. It should be like web server, EPMS, EMPMS web server. Same we can here. Match label, we should also change it here. For name is okay, but here I have to confirm, is it image available or not. Image is there, and what is the tag? Okay, tag is will be cut from here, is 1.0 4 years ago. Okay, then come back. Container port can be 80. Is there anything written in Docker file? No. Configuration file about the port. Here listening on port 80. Okay, we need this on port 80. EMPMS web server, should I copy? I think I have to change the one more time in the services, and here we are creating a service. Ideally we should create a one ingress for it, but I don't have DNS zone which can I map with this particular ingress. For what we can do, Now run this command. It shouldn't give us the error. And let's check what it say. What its log say. Application completed, ready for startup. Launching. Okay. So it also looks fine. Now, if you go again to overview, you can see you have 6 deployments, and with corresponding to that, you have 6 pods. What is this replicas? Let me see. Okay. They are saying that desired is 0, and that one gateway desired is 1. We don't have any. If you go to network, we have services for that. Now the main thing where we check, we have a web server, and if you go back again to the diagram, we have created the application, and we have this, their ports, on what port they listen, on what port they talk, Elastic, SQL. Here is the web server, send request to front end from here. So we should expose our web server to outside, and as I said to you, I don't have the ingress, and there is no meaning of going with load balancer. We can generally go with 80-90, we can say 80. Okay, localhost 880, it's getting redirected from here, and if we come back here again, if I run this on inspect mode, okay, now inspect mode is ready, and if you go back to website again, if I can close it from here, we can work it out on here. You can check, this looks like that, and same in the configurator mode we are getting. So we can go to add employee, like I'm adding employee or tap on target, and employee name target, and it's let me fill the address. Okay, I have filled all the detail. I don't know, there is nothing mentioned like it's mandatory or not, but I have filled like employee ID, name, address, email ID, phone number, annual package, role, status. Let's submit it. Okay, create. On creating the report, I'm getting the posted reports, and getting the 200 response. Assume that okay. So initial flow is get created. So now come back to here again. Here till the time we have not completed, we have salary, attendance, and notification pending, and if we click on the add attendance list, it's not working, it's giving the error because attendance is not ready for us. So what we have done till the time, we have used the images available on the GitHub account of the particular user, particular organization, which whom project we are using for our demo and our learning purpose. And I'm sharing my learning with you all. Here, what we can do for salary and attendance, we create our own images. We get log out, and but I'm assuming flow is very much clear to you, and how thing communicate and how things works in Kubernetes is going very easy for you. So if we come back to salary, or before salary we should go for attendance. Okay, here we have, it is also in Go YAML, Go language, have some configuration. Okay, EMPS DB, it's here it's check, here is password, but if you remember in the where is the DB, if I switch it off, we have MySQL there, and under the gates file we have the different password, so it will fail. To make it not to fail, we create our image here in the attendance, in the Docker file, and in the config file. We need to change this. Okay, we change this. Here it is saying that attendance API port 081, and like gateway is reaching out to attendance, and it will reach out to it at 8081 port, and MySQL is enabled, and DB name is attendance DB, and host is EMPS DB, and that's the port on which it is reachable. Username is root, and it's authentication for it. This is the password. Then we have, okay, we have this particular service. Now you are very familiar with this. This here, but demonstrating the very simple deployment files, and a simple cluster IP service. If we come back to CD attendance, and under that we have Docker file. We can use Docker build -t, and name of is the EMPMS attendance, EMP attendance. Okay, then dot sending Docker daemon. If we pulling from library Golang, as you see, they first interact with the Golang, first take the Golang public images and do some stuff, some kind of we can say the required files, and then run the build process for Go, and once it's done, it's run the second process like Alpine image, second one, and add some dependency under that, and give us a very lightweight image in the last. So it will initially, first time when you run it, it will take some time to to get the dependency in the local, and then it will create. For who's very new to Kubernetes should create all the Docker images from like I have creating for attendance and salary. Might be salary we will do or not. Attend for attendance we are doing. We are creating our own image. Then like that we can say for if you have in the second time when you use this images, you should make your own images and make your own configuration. And in this configuration, you should add some very important configuration like taint and toleration, node selector, and uh, we have more like resource management, which we have used only in one. Then PDB, you should define PDB for your ports. PV you should create. And there is one question for you. If you are creating the PV, what you are choosing, either dynamic or first you are creating a manual, and what are the your what you are thinking behind that? Why are is there anything which is blocking you for creating the dynamic PV, and how you are using this all the features? So till the time is getting created, if I go above, after the downloading all the dependency and images, it's run all the commands which were written in the Docker YAML file, and you can see go tractor running, and as this is very old version, and you can see it's giving some red flags there. I think it's get created. Docker images. First they check with the Alpine image, then they check with the Golang image, then they create their image, and after that they change their name. So I have my own registry. Here we can create a repository. What we can name is, we can say, give the same name. If I just, it will take just 1 minute. Let's create a repository in our in my, this is my own Docker Hub account. I'm creating this one. Then I can make it public. Later on you can use and make some modification under that. Let's create. Now I have to push my image here. Okay, first we need to run docker tag command. Okay, we should tag this as, this is the image which I want to tag, and what I want to tag is tag on target, AKS tendons, then v1.0. I think I'm in starting, so I should create this is as, okay, we check. Okay, tag on target EMPS is getting created. And after that we have the command docker push. Okay, it's working. And after that till the time it's getting done, here where was our repository? Yeah, that one. If we currently we have only one version, we can simply mention it this, and it will get, I am hoping this will get the one and only version. And here I can change it to here. There should be a space. Pushing is in progress. And let me check the other things here. We have deployment with the name and label of EMPMS, Employee Management System Attendance. I'm hoping it's EMPMS is Employee Management System, and its port is the 8081. And this is just an example of how you can deploy EMV. I'm hoping that. And service V1, it's API, and metadata is EMPMS, name, then cluster IP. Then we have again 8081 port. Okay, I think it's pushed. Okay, done. And confirm from here, start it. There should be a one version of image available here. Okay, V1 is available. Just run the kube command, and here come back. EMP Readiness is there, and okay. I think without version it will not work. EMP attendance, tag name, here is the tags, it's v0.1, and let's update it. There should be a colon in between, and let's run again. I think now it should work. Okay, it's listening on that. What was the issue? Issue just was we have put V. This was just a spell mistake. We have put the V in front of that. If we go back again here, first we check the logs. If you can see, the logs are okay. This seems to be okay. no issue with that. Okay, we are pending with the salary and notification today, and if I just send a request to him again, and here you can see one employee is already there, and add attendance will work or not. Employee ID I think was one. I think today date only should I fill. Submit. It's giving the 200 response. Then check with the list attendance. Oh, sorry, list attendance. 1% present on. Okay. In same way, salary you can also check. Currently, it will not work because salary is not ready. Same way, we can check with the. I found this project very good and for a learner to do its practice and a real time kind of scenario for this. You can use this project to get learning, and I'm thinking of it to make this project with full like a full project like with CI/CD monitoring, logging, all everything set up, and if anybody interested can join me and convert these can create like help chart for this for practices, and we will see if anybody interested. Thanks for your time. I hope you'll like this video. Bye. Much value from it. So that's all for today. Hope you like.